Hello and welcome back to the Patrick Family Kitchen. This is going to be a lesson on section 11-3 for statistics. I brought a puppet today. He'll be here for a little bit. His name is Biff, and just so you know, he's not a funny puppet. He doesn't say things or tell jokes or anything like that. He just does math. Okay, so he'll do a little bit of math and then he'll leave. And if you guys like him, maybe I'll bring him back a different day. Okay. So let's talk about what we're going to do here in this hypothesis test. In this inference procedure is going to be called the two proportion z test. Now I'll go ahead and write that down. And this is what it's called on a calculator as well. Hey Biff, just write that on the board, please. Okay. The inference procedure, like I said, is called the two proportion z test. Biff, you want to go rest somewhere now? Okay. All right. Now, so two proportion z test. What this test is going to do is it's going to attempt to detect a difference between two proportions. Okay, if you remember in 11.1, we talked about the two sample t-test, which tried to detect the difference between two means. This is kind of the same thing except for proportions. Okay, so what we'll do is kind of like normal. I'm going to do a hypothesis test while we write down the procedures for the two proportion z test. Okay, so let's begin. I'm going to pose a problem here from our assignment. A group of researchers were interested in how expensive would gasoline have to become before people were more willing to spend extra to buy an electric car, which might be more expensive initially, but would potentially save them fuel money in the long run. And so they asked a group of people. They asked 300 people. Okay, 300 people that were considered high income people. They made over $150,000 a year, and they found that the sample proportion out of 300, okay, the number of people that were willing to buy an electric car, if gas rose to $6 a gallon, was 244 out of 300. Okay, so what I'm going to do, again, this is the sample proportion. I want everybody to be clear here because I kind of talked a little there. This is, they asked 300 high-income people, okay, randomly selected from the population of high-income people, and asked them if gasoline became, $6 a gallon, would you be willing to buy an electric car? This is the proportion that said yes. Okay. They also asked a group of low-income people who made under $20,000 a year. And 300 people, they randomly selected them from among the population of people who made under $20,000 a year. And they found that the sample proportion was 202 out of 300. Okay, so this many people out of 300 would be willing to buy an electric car if gasoline rose to over $6 a gallon. Okay. All right. Sample proportion, that's P sub H, the sample proportion of high income people. That's P sub L, the sample proportion for low income people. All right. Now, what we'll do to start this hypothesis test is the same thing we've always done when we first start a hypothesis test, and that is to define the parameters of interest. So what we're interested in is there a difference between the true proportion of high earners an electric car if gasoline costs $6 a gallon or more. Now, I'm not going to write out the whole parameter of interest for the low-income people, but the pi sub L would represent the true proportion of low-income people that would be willing to purchase an electric car if gas rose to $6 a gallon. Okay, so you can fill in the rest of that at home. So we define the parameters of interest. Now, the next thing I would do is I would write down the sample statistics, which I've already done. I've written down the sample proportions anyway. N for each one of those is obviously 300. So I'm ready to write my hypothesis statements. And my null hypothesis would be essentially that there's no difference in proportion, in the proportion of high-income people that would buy an electric car and the proportion of low-income people that would be willing to buy an electric car. So the way I'd write that is pi sub h minus pi sub L equals 0. Okay. The proportions are the same. It's the null hypothesis. The alternative hypothesis, well, researchers didn't really have reason to believe that one group over the other would be more willing to buy an electric car. So I'm going to do a two-tailed test here. So my alternative hypothesis is that pi sub h minus pi sub L does not equal 0. Okay. So I defined the parameters of interest and I've made the hypothesis statements. Okay. Now let's talk about, and really these are the only sample statistics that I need. Okay. You remember I don't really have a sample standard deviation when it comes to inference procedures regarding proportions. So it's time to talk about checking the conditions necessary to be able to run this test. And the conditions are these. So I'm going to write check conditions or assumptions. One, each sample has to be a random representative sample. Okay, so I'm just going to write random from their respective populations. Now, next we have to check for normality of the sampling distributions. And so this is going to require 4 separate calculations. You do it the same way you did it for a one sample inference procedure for proportions. But now since you've got 2 populations and 2 samples, you've got to do it for both of those. So I've got to do n sub h times p sub h, n sub h times 1 minus p sub h, n sub L times p sub L, and then finally n sub L times 1 minus p sub L. All 4 of those have to be greater than or equal to 10 in order for us to be able to assume normality of the sampling distribution. Okay, so I'm going to say that all these have to be greater than or equal to 10. Now, in an actual problem, you would want to show those calculations. Okay, remember you just take n times p and n times 1 minus p for each one of these. Okay, and just verify that they're all greater than or equal to 10. Okay, so those are our conditions necessary for us to run the test. Now, let's choose an alpha level. Let's just do 0.05 for this one. And it would now be time to calculate the value of our test statistic. Okay, well, before we calculate the value of the test statistic, for this inference procedure, and only this inference procedure, we have to introduce something called P sub C. Eliza, how are we doing on time here?
9:33.
Okay, I tell you what, let's cut here. I'm going to do volume 2 or chapter 2, whatever you want to talk about, here in just a minute, so you won't have to wait long for the next video. Thanks. Bye.